Hi students, in this video we are going to solve problems related to integration by substitution. The first problem is evaluate integration of sin 2x divided by a square sin square x plus b square cos square x dx. You know that it is in the form of u by v. We do not have any direct method that can be applied to all integration problem which is in the form of u by v method. But this problem can be rewritten as sin 2x into 1 divided by a square sin square x plus b square cos square x. You know that 1 divided by a square sin square x plus b square cos square x is the composition function. In the composition function, this a square sin square x plus b square cos square x is the first function. We normally assume the first function of the composition function as t, and then we apply differentiation concept to check whether we are getting this sin 2x dx or not. We will try to do that now. Let a square sin square x plus b square cos square x is equal to t. When we do derivative on both sides, a square will be kept as it is. Derivative of sin square x is 2 sin x. We did the derivative for the power, and then derivative of sin x is cos x, plus b square has been kept as it is a constant. Then when we do the derivative of cos square x, it becomes 2 cos x to the power of 1, and then derivative of cos x is minus sin x, and in the right hand side we will get dt by dx. In the next step we can bring out this minus sign outside it, so we can rewrite the same step as a square into 2 sin x cos x. This minus sign has come out, so minus b square 2 sin x cos x dx is equal to dt. We brought this dx to left hand side. In these two steps, this 2 sin x cos x is common, so we can take it out as sin 2x also. So just you look at this, I skipped one step. So this is equal to sin 2x, so we just brought out sin 2x as common, so we get a square minus b square dx is equal to dt. As per the question, we must get sin 2x dx. Here we got sin 2x dx into a square minus b square. This term can be transferred to opposite side to get the required term. So we are just transferring it to the opposite side. Hence, in the question we can substitute in place of sin 2x dx as dt divided by a square minus b square, and then in place of a square sin square x plus b square cos square x is equal to t. So the question becomes like this: integration of 1 divided by t into dt is equal to log mod t, this constant as it is. In place of t we can substitute this a square sin square x plus b square cos square x plus c. I hope you understand this problem. Now we will move on to the next question, and the next question is evaluate integration of x square into tan inverse of x cube divided by 1 plus x power 6 into dx. Again, here 2 or 3 functions are involved. By observing the question, we can come to know that if we take tan inverse of x cube as t, by doing derivative we will get the denominator, and derivative of x cube will give us 3x square. We can get this expression x square dx also. So we will start with the problem with the assumption that tan inverse of x cube is equal to t. Then by doing differentiation on both sides we get 1 divided by 1 plus x cube whole square, and then derivative of x cube is 3x square, which is equal to dt by dx. This dx can be brought that side and x can be brought down, so we get 3x square dx divided by 1 plus x power 6 as t. So we can substitute dt in the corresponding place, and in place of tan inverse of x cube we can substitute t. So the integration has become 3 into integration of t dt. So the final value is 3t square by 2. In place of t we can substitute tan inverse of x cube whole square by 2. I hope it is an easy problem for you. Next we will move on to this question. Integration of root over of tan x divided by sin x into cos x dx. Our first aim should be to remove the square root, because we cannot get root over of tan x by doing derivative of the sin x cos x. So we can multiply both numerator and denominator by root over of tan x to remove this square root. So in the numerator we get tan x, and in the denominator we get root over of tan x into sin x cos x, right? And then this tan x can be written as, I already told you many times that whenever we get this kind of tan, cot, it is advisable to convert them in the form of sin cos. Hence we are converting this tan x using the formula sin x by cos x, and then the denominator as it is, and sin x will get cancelled. So the question becomes dx divided by this denominator cos x will come to the denominator. So we get dx divided by root over of tan x into cos square x. 1 divided by cos square x can be written as secant square x, and then root over of tan x. Now it is easy for us to solve the problem. If we take tan x as t, we will get this secant square x. So let tan x is equal to t. By doing derivative on both sides, we get secant square x dx is equal to t. Now the question becomes integration of dt divided by root over of t. And then when we do the integration, we get t to the power of 1 by 2 divided by 1 by 2. This 1 by 2 can be written as 2, and this t to the power of half can be written as root t, and then plus c. In place of t, we can substitute tan x. I hope you understand this problem. And then we can move on to the next question. It is an easy question. Evaluate integration of dx divided by square root of 2x plus 3 plus square root of 2x minus 3. Whenever we have these two square roots in two terms in square root, means we can take its conjugate and multiply numerator and denominator. It will simplify the problem. So we have taken root over of 2x plus 3 minus root over of 2x minus 3, multiply numerator and denominator, and we get the value as root over of 2x plus 3 minus root over of 2x minus 3. Here we can apply a plus b into a minus b formula, so that in the denominator we get this value. A square minus b square formula is applied. Now the integration can be separated, because in the denominator we have only one term, that is 6. So we can split the integration by doing the integration separately. We already learned when we have linear function, the formula can be applied. Whenever we have integration of linear function to the power of n, it can be written as linear function to the power of n plus 1 divided by n plus 1 into derivative of linear function. I just used that technique. So finally we get the answer. This is the final answer we get. I hope you understand this. With this problem, I am completing the video. Thank you students. Thanks for your cooperation.